Hey everybody, let's get started. Special relativity. I've decided to break my videos down into chunks so that when you decide to re-watch them you can just click on the chunk that's appropriate. So chunk number one is going to be about what does the special part in special relativity actually mean. Now many of you will already be used to using the word special when describing Mr. Watling and various aspects. But in this case, I'm going to start by discussing Newton's second law, which we're all familiar with being defined as the force is equal to the rate of change of momentum, and we're also happy with defining momentum as mass times velocity. And then if we were to say that there is a special situation, if the mass of the object doesn't change, then we can pull mass out towards the front of the delta and end up with delta V by delta T, which we all know is the definition of acceleration. So then we can write F equals ma. So when we see F equals ma in a textbook or in a maths class, we know that that is a very special case. We know that in this case the mass is staying constant throughout the story. So if F equals ma is a special case of Newton's second law of motion, special relativity is a special case too. Special relativity only applies to objects that are moving, that are not accelerating. This means all examples will involve stationary objects or objects that are moving with a constant speed in a constant direction. Trust me, this makes it so much easier. Accelerating objects is what general relativity is all about. Good luck with that when you get to university. But here we're just going to be talking about special relativity, and the special part is referring to the special case that acceleration is always going to be zero, causing the velocity to be constant.